All right, guys, this is the first of several lessons on space, Earth and space science. So we're going to start with our solar system and planets in our solar system. So our solar system includes the sun, 8 known planets, and the moons of those planets. All of these planets revolve around the sun, and they're divided into two groups: the inner planets and the outer planets. The inner planets would be these guys, and the outer planets would be those guys. You can note the difference in their size, and we'll also talk about their composition. As usual, please pause the video and go back if you need to write anything down. The inner planets are also known as the terrestrial planets. And this does a good job of their relative size. This guy here would be Venus, almost the same size as the Earth. This guy here is Mars, a lot smaller, and then this is Mercury. Mercury is a lot smaller, and this is also the order they come in. Mercury is the closest planet to the sun. I don't know what else to say about that, but although it's not the hottest planet, Venus is the hottest planet. Mars is a lot colder than Earth, and it's a lot smaller than Earth, therefore has a lot less gravity than Earth, which makes me wonder why people would want to go there sometimes, but I don't know. I'm not going, but maybe you'll go. Anyway, they're rocky planets. That's actually what terrestrial means. It means that they have rocky surfaces that you can stand on. So you could stand on these 4 planets. So Mercury is the closest planet to the sun. It has the shortest orbital period. Period means the time to complete a cycle, and the cycle in this case is go all the way around the sun. The surface temperature can be 400 degrees Celsius during the day, but 180 degrees Celsius, negative 180 degrees Celsius at night. So it gets up to a high temperature in the sun, but as soon as that sun goes away, then it gets extremely cold. And that's because it has no atmosphere whatsoever. No moons, no rings, no atmosphere. The atmosphere on Earth is what, keeps it warm, keeps that heat in there at night. Otherwise, we'd be dealing with the same thing. Venus is second. It rotates in the opposite direction from most other planets for reasons unknown. It is the hottest planet because it has a CO2 or carbon dioxide atmosphere. High in carbon dioxide. So what happens, though, it's still pretty close to the sun, not as close as Mercury, but all the heat that it gathers from the sun gets trapped in there in its CO2 blanket. No moons, no rings, and it is visible in our sky. Earth, third closest, third rock from the sun. Temperature varies from negative 85 to 65 degrees Celsius, although those would be very extreme. It's got one moon named the moon. Earth supports life, and water covers 70% of its surface. You already know a little bit about the nitrogen and the oxygen in the atmosphere, and that makes up most of it, and some other things. A little bit of carbon dioxide, too, which is increasing, which could be a problem. The fourth closest is Mars. Mars has 2 moons, and I believe they're called Phobos and Deimos, named after some Greek gods, I believe. It's known as the red planet because its soil is very rich in iron, which gives off a rust color because it's rusty. So it's called the red planet. It looks like this. I believe that I gathered this from an actual picture of Mars. It's studied. We've got rovers there looking at it. There's somewhat planned missions to Mars, although it takes like half a year to get there. So you'd be in a spaceship out in space for months just to get to Mars, and then what? So that's Mars. It's got the low gravity, like Earth has a gravity of 9.81, and Mars only has 3.7, so less than half of Earth's gravity. You would probably suffer lots of bone and muscle loss if you lived there for any amount of time. We could have a big discussion about what it would be like to live on Mars if we were having an in-class session on this, but unfortunately we don't. And then we got the outer planets. Outer planets are known as the gas giants. Guess what? They are mostly in a gaseous state. They don't have a solid surface. They supposedly have a small, dense core of liquid or solid elements, but that would be, way, in the middle, something like that, way in there. Jupiter is the fifth closest to the sun. It has 63 moons. It has a thin visible ring, not as easy to see as some other planets that'll be coming up next. It has many colored bands. It is the largest planet in our solar system. It's got the Great Red Spot, which is a hurricane, which is larger than two Earths. That's this guy right here. Larger than two Earths. So when we're talking gas giants, these planets aren't just a little bit bigger than the terrestrial planets, they're a lot bigger. So two Earths, you're looking at two Earths like that. The storm is bigger than two Earths. I also read somewhere that it's been going on for thousands of years, that hurricane. Saturn is the sixth closest. It has 60 moons. It has more than 1,000 rings made up of chunks of ice and rock. It's the second largest planet. It's the one with the visible rings. If you had your own telescope, you might even be able to see them. It's got a very low density. It says can float on water. Really, it's just emphasizing the fact that the density of the planet is less than water's 1 gram per milliliter. I remember reading that when they first found it, what they thought they saw, because the resolution on their telescopes at the time were very limited, because they could kind of see those rings, but they were blurry, they thought they discovered a planet with two big moons on the side, but really they were just seeing that ring going around it. Uranus is the seventh closest. It rotates in the opposite direction from most other planets. It's tilted on its side. It really is what we're talking about. It's the third largest planet. It's almost completely on its side. See how its ring goes kind of up and down? It is mostly its atmosphere, if you want to even call it that. Basically, the whole planet is composed of mostly hydrogen and methane. Methane is actually what it gives it its blue hue in the sunlight. So that's certainly worth mentioning, is that there's hydrogen and methane gives it the blue hue. Same with Neptune. It's blue because of that methane gas. It's the eighth planet, and it appears blue because of that methane gas. But Uranus appears a greenish blue as well. That is the planets. I should also mention, because we're going to have an abbreviated chapter here, obviously, that between the terrestrial and the gas giants is where the asteroid belt is. And that is where most of the asteroids are in the solar system. I did read somewhere not too long ago that Jupiter seems to save us from the asteroid belt, with the asteroid belt somewhat close to where the Earth is. It's between Mars and Jupiter. Some of those asteroids do stray and could destroy the Earth, but most of the asteroids that stray away from that belt get trapped in Jupiter's gravity, and Jupiter just takes them in. So I have heard that has saved us a number of times. Do I need to say anything else about that? No, I think that's our solar system. Basically, you might be thinking, hey, what about Pluto? Isn't that a planet? No, it's got relabeled a dwarf planet, I believe, because, well, they found lots of other planets that were kind of like Pluto out there. They thought, well, if Pluto's a planet, then there's lots more Plutos. So they called it a dwarf planet, and then I believe they identified a bunch more dwarf planets, none of which I know the name of, but we can certainly look them up. So that's your intro to the solar system. Next, in a couple of days, we're going to look at the formation of the solar system, and then the life cycle of a star like our sun, and the life cycles of other stars that might be bigger or smaller than our sun. All right, guys, I believe that is it for now. What I want you to work on today, if I have it, your task is as follows. Not here, I got to go to your class. And if I go here, our solar system, and we just went through that. There's nothing to hand in here, guys. I just want you to watch this video, which we're doing now. And I want you to just read through this section, and it goes through lots of the stuff that I just talked about. It's got this stuff about Jupiter and dwarf planets on it. It talks about the asteroid belt, the difference between meteors, meteoroids, and meteorites, which, if we were having a test, would be terms I would want you to know. Talks about comets. My brother Joe, he's a geologist, and he studied comet impacts. And that's about it. I don't need you to do these questions. I just want you to read through the section. Anything in that section confuses you, send me an email or get in on the comments on Google Classroom. And I know it says there watch and there's nothing there. There's a video I want to attach to this. And it talks about the likelihood of finding other life in our galaxy or even in the universe. Okay, but that's going to be it for now. So I'm going to sign off. Good luck with your studies here, and don't be afraid to contact me if you have any questions.